Okay, so we need to do the mixture problem. So that is number 11. The ice cream problem, number 11. This problem is on the test, just like all the ones we did yesterday are on the test, okay? So what is our strategy for a problem like number 11 where we are mixing things together? Amount times percent plus amount times percent equals amount times percent, right? That's our strategy. So, do we know all of our percentages?
Yeah.
Yes, we do. So we're gonna fill those in first. I mean, it really doesn't matter. I'm gonna fill them in first. So I'm gonna fill in all my percentages. So
8 times.
I got 12% and 20%, and I want to get 14%. Does that make sense to everybody? Now let's fill in our amounts. How many gallons of vanilla? Don't know. Call it X, right? How much? Well, I should take yours. Mixed with 18 gallons of chocolate to get some. That is not X. Well, you could call it Y, but it's easier than that. Because what do you know about this? Isn't that these two mixed together? Right? X plus 18. Not 18 times X, not 18X. So think about it like this, you guys. I have a big bucket, and I'm going to dump in X, and I'm going to dump in 18. How much is in the bucket now? 18 plus X, right? If I dumped in 5 and 6, it would be 11. So that's what I got. This one right here, this amount right here, is always going to be these two amounts added together. All right, so now I just do my arithmetic. Where's my calculator? And I'll just solve my equation. And I got 54 gallons. Was it gallons? Yeah, 54 gallons. I'll let you check that and see if that's what you got. Do want to caution you, when you combine your x's here, you know, when you start solving this equation and you subtract, 0.14 minus 0.12 is 0.02. Not 2, not 0.2, it's 0.02, right? So be careful. You'll have your calculator so you can figure that out. All right, so that's the one I wanted to do because now I have done every problem on the test.
So if there was an 18, there was a y where the 18 was, would the parenthesis on the right be x plus y, or?
Yeah, but I don't want two variables.
So you would obviously have to make it x.
You'd have to solve the y, get rid of the y. Yeah, if you put two, if you put a y in, it's fine, but you have to get rid of it.
Can I see an example?
I don't know, find one. That was your job. Your job today was to find something. So who found a problem? Tell us which sheet we're looking at and what the problem number is.
I was confused on the front page on the number 3 because I thought when I solved for y, am I able to get the same thing?
So we're looking just on the very front page. This is a test question. It says find the inverse of 2x plus 1 over 3x minus 2. So we'll switch our variables, so x equals 2y plus 1 over 3y minus 2. Remember, this is like y.
I'm like 3y minus 2.
And we multiply this over to here,
Because you moved it.
right?
The y's on the wrong side.
And then we'll first I distribute. Hey, is everyone keeping up here? Following what's happening?
Yep.
And then, because I'm solving for y, I have to do the great switch here. I have to get my y's on the same side. So 3xy minus 2y equals 2x plus 1.
It's the same. Okay.
Remember, I'm solving for y. So now I'll factor out the y. So I only have 1. And then I divide. And that is my answer, because I'm going to divide by this parentheses. Now, his question was, I did all that, Mrs. Ford, and look what I ended up with. What did I end up with? Same thing. There are functions out there that are their own inverses, and this is an example of one, okay? So yeah, that can happen. You did all the steps perfectly right. You're good to go. Good to go. Yep.
Number 3 on the third page.
I don't know which one is my third page. The one you can hardly read. Yeah. It says quiz 1.5 to 1.6. It's really faint. And number, I don't have 3. Oh, that's a 2. Yeah, it's number 2. Yeah, so number 2 says, write a single equation in x and y. This is a test question. We did one yesterday. How do we write a single equation in x and y?
Solve for t and then plug in.
Solve for t. One option would be to solve for t and plug it in, because when we're doing this, we need to lose the t's. The t's need to go away. So one option would be just to take this equation up here, subtract 3 and divide by 2. How did I do? Is that okay? Is that all right? Then I'll take this and put it here. So y equals x minus 3 x minus 3 over 2 squared. That's your equation.
You know what the solving for anything?
There's no solving to do. Now, could you FOIL it? You could, but there's really no need to, because I'm not going any further with the problem. If I had a step 2, I would probably do that, and you certainly can. You absolutely can. That would be a FOIL on the top and square the bottom. Yeah, so if you wanted to do x squared minus 6x plus 9 over 4, that would be fine.
So we stop when y is by itself, or like.
You stop when there's no more t's.
Okay.
There's no rule, in this case, it came out with y by itself, but there's no rule that says y has to be by itself. You just can't have any t's.
Where'd you get x squared minus 6x plus 9?
I FOILed that.
We don't have to, though, you said.
That's why I already said that. I just did in case somebody wanted to. All right, who else found one? These are both really good questions. They're on the test tomorrow.
Do, 5A on mistakes.
Extra practice 1.7. Extra practice 1.7. What am I doing?
5A.
5A.
Or taking the y's out.
Okay.
Replacing with X. Fair.
Okay, so your job was to go find problems like we practiced. We didn't practice that? We didn't practice that.
About
Did we practice that yesterday?
4.
Did we practice it yesterday?
I think so.
No, we didn't. No, you need to keep track. I mean, I don't care what you study, you can study all of this, But my job yesterday was to focus it in for you, so you knew exactly what I was gonna ask you on the test, right?
So that I can.
The problems I practiced yesterday, plus the mixture problem that we did first, are the ones on the test, okay? Charlie, when you play a tennis match, you don't know exactly where that ball's gonna go, right? Okay, I'm telling you exactly where the ball is going, I told you yesterday. Yep,
The one we did before, it's on quiz 1.5.
okay,
Number 1.
so back to, his paper, says quiz 1.5 to 1.6. And the first question is just like this one, except easier. The first question is find the inverse. And then, once you found the inverse, find the domain of it. So here is the function. So to find the inverse, I'll switch my variables and solve for y. This one is much easier because there's only one y. So there's the inverse right there. The inverse is going to be 7x plus 8 over 5. How do we find an inverse? We've done 2 of them now this morning. Switch the variables and then get y by itself. When there's only one y, that's easy.
On the test, when we write down the inverse answer, does it have to have the like f of
It
negative?
does. Okay, now we have to find the domain. And the domain is all real numbers. Why? Guys, nothing affects the domain, well, as long as it's not a word problem. Word problems are kind of different, but in a regular equation, if I don't have a denominator, and you're saying, you have a denominator. No, I don't. I mean, I do, but it only matters if there's an x down there, right? 8's don't matter. So if I have a variable in the denominator, I have to be on the lookout. Or if I have a radical, I need to be on the lookout. I don't have either one of those, so this domain is all real numbers. That's just gonna be some line when I draw it.
Are you using for a
On what page am I on?
It's right behind the first page.
Right behind the first page. Oh wait, I'm on the wrong page. Right behind the first page. 4A, which is a sketch. Yep. So we are gonna have to sketch on our test. So it's on the back of the front page, the back of the very first page. And the original picture is this. Alright, so there's my original picture. And now I'm going to graph that. So before I jump in to do that, let's talk about what I'm doing. What am I going to change? What does this do?
Divided all the negative by divides all the x's by negative.
Okay, so what impact does that have on my graph?
Switches it.
Flips it, so this is a sideways flip. So that means everything that was on the right in the original is now just gonna be moved over to the left, and this is gonna go over here. What is that going to do?
Up one.
Up one. Now, you guys, some of you can do that all at once. I'm gonna do it in 2 steps, because I can keep track of it better that way personally. So my little semicircle here is gonna come to the other side and look like that. So this guy right here, 2 wide, 1 tall, there he is, over here. Then my triangle, and my other little semicircle. Does that look okay for just this part of the problem? Then I'm going to take everything and lift it up 1. Now you don't have to draw that line in, that is not required. But I kind of think of the axis as like my baseline. and the baseline is now getting moved up one. So every point is getting moved up one. So the green thing would be my answer. Every point got lifted up
Can you
one.
just do the next two on the page?
Okay, Jake, you're
No,
gonna
actually,
be doomed
B-
if you don't know your rules. You gotta know
B is,
your rules.
B is easy, what about C? I'm just confused with you.
What happens with
Do
C?
you change the height, or like, I don't know what you do.
The height,
It's only an inside.
the
I
inside
know,
of the
but-
outside.
We multiply the height by
Two.
2. So we go back to the original picture, and instead of this little circle being up 1, he's now going to be up 2. His height gets times by 2. And the triangle, instead of being up 2, is now gonna be up 4. And the semicircle is gonna go down 2. So there it is. Okay, these are not hard, but you have to know the rules, or you know, can't do it if you don't know the rules. So a coefficient out in front multiplies the height. A coefficient in here divides the width. All right, what else have you found? Yep.
Can you do 13 on view 1.5 to 1.7?
1.5 to 1.7.
The second one. Number 13.
13. Okay, I did that yesterday.
Oh, okay.
I think, if I'm looking at the right paper, I did that yesterday.
This?
No.
We did 12.
Oh, this is review number 2.
Yeah.
Okay, sorry about that, I didn't pay attention. Review number 2, number 13. We did some cylinder stuff yesterday, so let's see what this one says. A cylindrical tank has a diameter of 12. It's a cylinder. Has a diameter of 12. The water in the tank is 6. Okay, no, we didn't do that. The kind we did was, I'll do another one like we did yesterday. The diameter of a cylinder is 1/5 of the height. Write the volume in terms of the radius. And that's what we did yesterday. Okay? I made this up just now. All right, so who remembers, where did we start with all of this? Dana?
You have to figure out what the height is first.
What's my formula? I'm gonna be basing all
Pi r
this
squared
on.
height.
Pi r squared h. And this formula is perfectly wonderful, but I'm supposed to only have r's. So I gotta focus in on the height, like you said. So what do I know? The diameter is 1/5 the height,
Yeah. So there's 5 diameters.
which means the height is 5 diameters,
Which is 10 radiuses.
and the diameter is 2 radiuses. So I'm gonna take this out and put in 10R. So my volume will be 10 pi r cubed. Right? All right, what else?
Did we do number 11, or I don't think we
On this same page? Well, this is a mixture problem, we haven't done it, but it is on the test, so, amount times percent. You don't have to write this out, I always do. Hint, hint, I always get my problems right too, so it might be a good idea to write it out. Write it out. Fill in all your percentages, so what are they? This is number 11. So I have 5%, which is 0.05. Mixing it with 12%, and gonna end up with 8%. Right, so far? Now I'm gonna put in my amounts. How much? 8 ounces,
And X plus
and I don't know what this is, but it's these two added together. So X plus 8? So 0.05X plus 0.96 equals 0.08X plus 0.64. Hope my arithmetic is okay. Then I'll start solving. I got 32/3 ounces, but I could have made a mistake, so I'll just wait.
That was it.
What you got? Okay? Let me just check something real
Miss Ford,
Yeah,
would you take that as a decimal?
as long as it was rounded, like it was supposed to be rounded, so if the directions say rounded, and there's thousands, make sure whatever you get, you round it off right, but yeah.
Okay.
Let's try this mixture problem, since we didn't do any yesterday, we'll do one more here. Let's suppose, we wanna know, how much 15% to be mixed with 92% to get 80 pints of 31%. Yeah, that's not on the sheet, I couldn't find one like that, so I made that up. Okay? So here we go, about 10%, all that stuff. So, what are my percentages? I always have those, fill those in, what have I got? 15%, 92%, 31%. So far, so good? How much, there's that X, to be mixed with 92 to get 80 pints of 31? Right? Now remember, these two added together have to be 80. So if you can't visualize this, think of that as Y. X plus Y have to be 80, right? So what is Y? You can't do the problem with Y. You have to get rid of it. So Y is 80 minus X. So I'm gonna put 80 minus X right here. And I'm gonna solve my equation. These two have to add up to this one. So 15X plus 73.6 minus 24. Now don't get carried away. This is a regular equation. What are you gonna do first when you solve this? You're gonna combine your like terms. That's exactly right. Don't be screwing around with stuff till you get that taken care of. So negative 0.77x. By the way, 77 was a great year. That's when I graduated from high school. And we'll, yes, people, I am aged. So negative 0.77x equals negative 48.8. I'm not worried about those negative numbers because they're gonna cancel out, right? I would be worried if my answer came out negative, that would be bad. So I got 63, 0.377, is that what you got?
Yeah.
Alright, so that's now 3 or 4 mixture problems we got, so we got that covered.
You don't have to get both of them or no? Like both X's, like one of each. Because they're mixing two different things, so you get both the X's.
No, it says how much 15%, so the answer is that right here. That's how much 15%. If I wanted to know this one, I'd just subtract from it. Alright, one more before we go. I'm starting with this function. And I'm ending with this function. And you need to tell me what changes I have made. And I think I made 3 changes. So I need you to tell me what they are. So first of all, everybody's cool. This is a parabola, and this is a parabola, right? So I am taking, they're the same size. I'm taking them and doing things to them to make this one map onto this one. So what are some things I have to do?
Flip it upside
I
down.
gotta go upside down.
And then you go,
Down 5.
Now, where is this one sitting?
you go left one.
Left 2, up 1. Where's this one sitting?
Left 3.
Left 3, down 4. So in order to get from here to here, I'm gonna go left 1. And then to get from here to here, I'm going to go down 5. Right? Alright, I'll see you back at 45. I'm with questions. We have another half hour and then we're
I have a question about this. How'd you get, when did you get to
we got distributed. 87.92 and.
Oh, 80 times one X.
Yeah, yeah.
Great. I'm locked in. That is great. That's because I'm locked in.
Okay, have you taken notes? Watch the video?
I know.
Everything else I just did.
Okay, but that's in the notes. So if you watch the notes or watch the video and take notes and then still can't figure it out, I'm happy to help you. But there's a rule for that